Hello, I'm Christopher Frenfeldt, Business Development Manager at SWEP, one of the world's leading manufacturers of heat exchanger. Thank you for joining us. At SWEP, we believe our future rests on giving more energy that we can take from our planet and our people. That's why we put our efforts into leading the conversion to sustainable energy usage in heat transfer. In this presentation, we will explain several of our energy savings applications relating to heat networks. Such networks are set to play a key role in the future provisions of affordable, sustainable, and low-carbon heat. But first, I will explain the principle of a compact braze plate heat exchanger, often shortened to BPHE. BPHE are highly efficient products that enable the transfer of heat and cooling from one source to another. This is achieved through what we call the flow principle. This involves two channels. One carries hot fluid, the second transfers cold fluid. The two channels are separated by corrugated plates through which the heat transfer takes place. So now, join my colleague Adam Raymond, who will take you on our drone flight through the district energy landscape and discover our applications that play their part in decarbonization of the planet. Enjoy the tour.
Energy centres are the main source of heat for district heating networks. Energy sources include biofuels, combined heat and power, and energy from waste. Where the energy centre is producing excess heat, this can be turned into electricity through a process called the organic Rankine cycle. Organic Rankine cycle technology involves a turbine set in motion by the pressure of a fluid which has been vaporised by excess heat from the energy centre. In optimal conditions, electrical efficiency of up to 20% can be achieved for the largest plants that utilise waste heat from the large gas turbines. If there is a local heat demand, the rest of the energy will be delivered as heat to the local heat network, meaning total efficiency is close to 99.5%. Solar thermal farms, often involving banks of solar panels, are an increasing source of renewable energy around the world. In Sweden, SWEP has worked closely with Absilicon Solar, which has developed a solar thermal farm that connects to the local district heating network using our high-capacity B649 brazed plate heat exchangers. Geothermal plants transfer heat sourced from below ground level for use in a district heating network. For every kilometre you drill down, the Earth's temperature increases by 20 to 30 degrees C. So, at 7 kilometres below the surface, geologists can be confident that water can be naturally heated to around 140 degrees C. One example of this is a project in Sweden that will use the so-called hot dry rock technique. One borehole is used to inject high-pressure jets of water into hundreds of cracks in the hot solid rock beneath the city. The water is heated naturally to 120 to 140 degrees C as it is pushed through the rock. It is then pumped to the surface using another borehole approximately 200 metres away. At the surface, a SWEP heat exchanger transfers the thermal energy from the underground water to the water that is pumped through the district heating network. Heat pumps warm and cool buildings by transferring heat taken from a cooler space, like an open surface water source, to a warmer space using the refrigeration cycle. For every kilowatt hour of electrical input, up to 4 times as much energy can be generated as thermal output. Geothermal heat pumps are rated by their energy efficiency ratio and the coefficient of performance rating, which is much like miles per gallon for a car. The higher the rating, the more energy efficient the system. When heat pumps are supplied with electricity from renewable sources such as wind or solar PV, then we really have a carbon-free source of heating for our sustainable city. Surplus heat, for example heat from machines or industrial processes, can also be used for heating applications. One example is in the data center cooling industry, where unwanted waste heat can be recovered using our SWEP brazed plate heat exchanger technology and supplied directly to the district energy network. Due to the fact that waste heat is an unwanted byproduct from another application, it has a very low carbon footprint. There is quite a high potential all over Europe for waste heat recovery. However, there is also the issue of economic feasibility to implement a heat recovery system.
Thanks for that, Adam. I hope you enjoyed the tour, and for more information please visit swep.net. And now in the background you can see our virtual showroom, and by clicking the link in the resource tab you can meet me there and learn more about our products. See you there!